What's up, everybody? I'm Matt Gary, and in this episode of Coding with the Force, we're going to go over the single responsibility principle. We'll go over what it is and how you can actually implement it in both JavaScript and Apex. Alright guys, so today we are going to go over the single responsibility principle. We're going to find out what it is, why you should use it, how it can benefit your code base, and then we're going to go over actual examples of how to implement it in both Apex and in JavaScript. They're not super different between Apex and JavaScript, but I'd like to give you a practical example of both of them so that you know how to use them if you wanted to. But before we get into the magic of the single responsibility principle, I wanted to make you guys aware of two different things if you weren't already aware of them. Number one, 2 random people that subscribe to this channel and 2 random people that share this content and tag me in social media get free Salesforce certs up to $200 in value on me. Now, you still got to pass them, but the first try is on me. The second is that there are now channel memberships, and those channel memberships come with cool things like the ability to ask me questions in a private Discord channel. If you get stuck, you get lost, you can contact me for help. The second is, you get extra voting rights, and there's a couple of other things too. And those channel memberships go a long way to making this channel better than it is today. So they go towards things like getting guest speakers who are more knowledgeable than myself, getting equipment that are that's a little better for recording, and towards more certs for you guys in the future. So definitely check it out. All of that membership money goes back into this channel to make it better and a more useful resource for everybody out there in the Salesforce ecosystem. So that's it. Let's get back to the video. All right, so first thing that we're going to go over, what is the single responsibility principle? This is something that I feel like if you Google it on the internet, all right, yeah, obviously, it doesn't give you quite the definition that you'd hope for, and it doesn't give you what I would consider even the right definition, at least the first few links that I find or videos. The most common thing that you'll find out there is that a module should have one and only one reason to change. And this isn't necessarily wrong, but it's not exactly what I would think is, it's not as informative as it maybe should be. So, number one, what is a module and what should its one reason to change be? It could be a lot of things, right? It could be a class, it could be a method, it could be a whole application. I don't know. Maybe it's all of them. The second thing is, what should its reason to change be? Is it just because you've made this class to deal with opportunity calculation, and it should only have to change because of you're changing the way that opportunities calculate? I don't know, right? It's not very clear exactly what that means. Like, what should you focus on when you're trying to follow this principle? I think a better definition actually comes from Robert C. Martin's Clean Architecture book, which, if you didn't know, Robert C. Martin, while he didn't come up with the principles themselves, he kind of formed the solid principles by condensing a whole bunch of computer science or computer engineering principles into the solid principles. So, his definition in this book of single responsibility principle is a module should be responsible to one and only one actor. And if you don't know, an actor in software architecture is a group of people. So basically what he's trying to say there is a module that you might change should only change because one specific group needs it to change. And it should only be responsible for that one specific group. And an example I gave in, I think, the last video where I went over all the different solid principles is that, say you have an opportunity calculator like we were just talking about, And right now, you've just got an opportunity calculator that is for everyone. And everyone is a whole bunch of different groups of people. Maybe that's sales associates. Maybe it's, your high-level executives like CFOs and stuff. Maybe it's your managers. And the problem is, what if that changes, right? Originally, the opportunity calculator is fine, but in the future, you find that the opportunity calculator needs to be different for sales associates, managers, high-level executives. Then you have a problem. You have one class, and that opportunity calculator class is going to have to change every single time any one of those actors wants a new piece of functionality in it. And it'll be irrelevant to 2/3 of the people using the opportunity calculator because you've kind of condensed them all into this one class, right? And so you have to change it for a bunch of different reasons, for a bunch of different actors, and it becomes more and more complicated, and the class becomes more and more complex over time. And the idea is to move away from that and make an opportunity calculator that works for each one of those groups of individuals, each one of those actors. And and that way you have a lot more flexible code base, right? You can kind of easily say, okay, managers, you want your opportunity calculator to calculate things this way. Let me just go into my class for opportunity calculators for managers and change the method there, instead of going into the combined class and having to, mess with an if statement or multiple if statements that say, like, if I'm a sales manager, it calculates this way and it outputs that way. It can just be a whole lot more challenging to deal with. So I think that's a much better definition of what the single responsibility principle is and kind of what it hopes to achieve. It is asking you to make your classes responsible to one and only one group of users in your org. And, I guess the follow-up question to that, at least in my mind, would immediately be, okay, but shouldn't my classes still only have one function, right? And shouldn't my methods still be small and have one function? Isn't that the single responsibility principle? And my answer to that is yes, and kind of. Yes, you still want your classes to have one function for those actors. So if you had a opportunity calculator for salespeople or sales associates, you wouldn't want it to be an opportunity calculator and an opportunity converter for sales associates in the same class. Those should be two separate classes for sales associates. You still want your classes to do one thing, and you still, it's just that you want them to do one thing for one group of people. The other question about methods, should they do one thing? Absolutely. But these are what I would think of more as clean coding techniques as opposed to necessarily the single responsibility principle in action. And I say that because, the reason that you want a class to do one thing is because when the class does one thing, it's easier to know what it's actually doing, right? Same thing with a method. If I'm creating a method with 10 lines of code, it takes me 10 seconds to read. But if I make that method 30, 40, 50 lines of code, it's going to take longer and longer for me to figure out what it's actually doing and what I might need to fix in that method to make it work, right? The single responsibility principle, on the other hand, is trying to tell you separate your code for your different actors so that the architecture, the overall architecture in your org is a little more separate, and that each of those groups of actors can get updates to their specific code base quicker and easier, and it's less of a pain for you as a developer to fix things for them. So, yeah, I think we went over the how, the what single responsibility principle is at this point. I think we've really gone over the why. I can quickly recap it though. Basically, the single responsibility principle is going to make it so that your actors' code bases are kind of separate and make it easier for you to fix a problem for, actor group 1 and actor group 2 when they're in their separate places, right? If they're all stuck in the same class, you might break it for every single one of them on accident, when you're fixing things. But if they're all in separate classes, well, the dependencies are lower, the potential for failure is lower. It just makes it so that your code base is nice, separated, and easier to deal with on a day-to-day basis for every group of users in your org or your, whatever you're building. So, all right. Now that we've gone over all the things, I feel like, what it is, why it's useful, all that kind of stuff, let's actually see an example of this in action. We'll build an Apex class for multiple actors, multiple classes for multiple actors, and see how we can do this in an efficient way that actually works. All right, guys. So to start us off, I've got an Apex class in front of me that is the op calculator we talked about. Obviously, it's, there's not much going on here, but we'll stick with the op calculator example that I keep going back to over and over again. And the op calculator combined service class here does one thing. It just calculates opportunities, but it still doesn't abide by the single responsibility principle because it's doing that for the CTO, a sales associate, and a manager, right? 3 different actors. So even though this class itself is just worried about calculating opportunities in our org, it's doing so for 3 different user types. So we have to figure out, how do we design something that works in all these different scenarios, in our 3 different actor type scenarios, but in a controller over here? So I've just got a simple controller that you could maybe use with a Lightning Web component or an Aura component, and it calls that op calculator combined service calculate ops. So we've got to figure out together here, how do we break this up and make it still so that we only make one call here, right? We don't want to have to make an if-else statement in this controller too, or else now our controller breaks that principle. So that's no good. Which is tricky, right? And I will say, what I'm about to get into, there are a couple other videos that I have made that will help you understand what I'm about to do even more, because I go even more in depth than I'm going to go in here about them. There's a video about interfaces, and there's a video about the factory pattern. And if you want to know more in depth about either of those 2 things, I'll put a link in the description or maybe up above too. And you should definitely check them out because they're worth knowing. That said, you don't have to watch them, but they will give you more context into what I am about to do next. So with that said, let's get to it. Let's figure out how to break this class up so that it only works for, we have a class that only does work for the CTO, one that only does work for a sales associate, and then another one that just does work for the manager. All right. As you can see, I think, even in this simple example, we've got this if statement. And as you could easily imagine, I think, this could be quite a bit messier, right? You could be doing a lot more things for each actor type or group of users. You could be, prepping the opportunities, then calculating them, then, reordering them based on certain criteria. Who knows? And it could be different for each one of these. So you could have multiple method calls. You could have multiple, tons more methods in here. And it could just get really, 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 really messy, right? So let's figure out how to break this up. The first thing that we're going to do is we're going to create an interface. Again, if you don't know what interfaces are, definitely check out my video. I go really in depth on what they are, how to use them, all that kind of stuff. The first thing we're going to do is create an interface. And we'll call this the op calculator interface. And I will be the first to tell you, I write my interface classes a little weird. I like to do an underscore interface at the end. Plenty of people would heartily disagree with me. And most interface classes are just going to have a capital I on the front of them. But I don't think that's as clear, so I don't do that. So we've got op calculator interface. So I need to change this to an interface. And if you don't know what interfaces are, they are contracts that other classes have to abide by. And all you put in them are the stubs of the methods that you want another class to be forced to implement. So we are just going to have this void calculate ops method. We don't even need a user type, which is going to be cool. So we'll get rid of that. And you don't need brackets here. We just need that guy. Now you'd probably want to actually return something in the real world, but we're making a fake example to figure out how this all works together. Okay, so we've got this interface and we've got this combined service. Now let's break this out into a few classes and figure out what we need to do. So, right, I shouldn't just click that aimlessly. We need to call this op calculator. And we will call this, well, what should we do first? CTO. Op calculator service CTO. Yeah. And I'll zoom in on this, and we will have this implement our op calculator interface. Cool. And if you didn't know, if I tried to save this right now, it's going to give me an error, and it's because I'm implementing this interface. And if I implement this interface, what I'm saying, or what the compiler is going to expect of me is to implement this method, calculate ops, in this class. If I don't, then it'll say you can't save me because you didn't implement this method yet. So we're going to make this a public method called calculate ops. And we will just do in here what we did in this method down here, because now we don't need this extra method, right? At least in our scenario, we don't need an extra method. We can just say we're doing CTO ops, right? That's what we're doing here. And we'll just replicate this for the same thing. Now, you might be asking, well, what is the benefit of this? Obviously, this class itself is immediately way simpler, right? I don't even need to think about what's going on here. I don't have to look at this if statement and think about it. I just know this is the CTO op calculator, and this method is calculating ops for it. If this spanned and had tons and tons of methods, right? Well, then, like I said, this could get pretty ugly looking, and the simplification that you can see just from one method could be pretty extraordinary with lots and lots of, additional logic here. So, okay, so we got this calculate ops method. Let's just make this for our other guys too. We'll say op calculator, calculator service underscore, what are the other ones? Sales associate. I'm not going to do that. I'm going to be SA. Actually, I would never do this. Sales assoc. I'm a guy that likes clear clear terms. And again, we're going to make sure that it implements this interface, and it will all become very clear why I'm using this interface here soon, I hope. And we're just going to grab this method again, place it in here, but this is sales associate ops. And one more time, we'll do it for the managers. Op calculator service managers. And manager ops. Cool. So 3 classes. They all, oh wait, forgot to make this one actually implement the op calculator interface. That will absolutely for sure be important. And we've set all of our classes up. We've set our interface up. Now let's figure out how do we actually make it so that this controller here doesn't have to make its own if statements and be difficult and confusing and irritating. So yeah, let's get into it. All right, so the next thing that we are actually going to build together is a generic service that this calls. It has no idea about these classes, these actor-specific classes. It never will, and that's a good thing. And that is what our controller will actually end up calling. So let's just create a new class, and we will call it, we'll just call it op calculator service. If you don't know what service classes are, why I keep calling things service, I should have got rid of the underscore here. Mostly because I'm calling everything else without an underscore. That's going to bother me. Oh well. If you don't know what a service class is, I do have a whole video tutorial over service classes. So definitely go check it out. I'll put it in the description too. Basically, it's a class that houses your business logic. Super important that you kind of separate that out. And the other video goes over that quite a bit more in depth. I'm not going to go too in depth about it here. All right, so basically what we're going to do here is create a public static void. What did we call this everywhere else? Calculate ops method. Just to be consistent, technically you do not have to name this, because as you see here, I am not going to implement an interface here. I don't want to. The way that this works, that I'm about to show you, for this kind of abstract one, you don't need to. I mean, I suppose you could, but that's not its purpose at this level. And I am going to create a map that this class can use. So we're going to say private map string class name. Or, well, this will also be a string, but it'll end up being a class name. And we'll call this user type to calculator, if I can spell, calculator impl or implementation. And then we'll say new map string, and we will actually create our map here. So if you didn't know, you can do maps inline, like I'm about to show you here in just a second. But what we will do is, actually, we can just make this a type, I think. Type. That'll be a little bit easier. Yeah, cool. So we'll just say, if we get our CTO string in here, then we're going to map that to the op calculator CTO class. If we get the sales associate in here, user type passed to us, then we'll map that to the op calculator service sales associate class. And manager, if it gets passed in, we will map it to the op calculator. I cannot spell this word. Calculator managers. There we go. And there we go. So we've got a map that maps basically our user types to an implementation, a class implementation, or a class type. All right. And what we will do here in this static method is we'll basically, oh, I did forget to have this pass in string user type. What we'll do is basically just say, what is the name of our interface again? Op calculator interface. Op calculator equals user type. Oh, it's because this is static. That is important. I was confused why I wasn't auto-completing there for a second. Dot get user type dot new instance. And it's complaining because it doesn't know, it doesn't think that you're going to return to it an op calculator interface type, which is a fair assumption by the compiler. It doesn't know that. So you need to cast it to the interface here. And again, in the interface lesson, I go over this way more in depth and in the factory pattern. So definitely, if you're lost here in any way, go check out both of those videos and come back and you will not be lost anymore, I promise. All right, so basically what are we doing here? We've got this map of user type to basically op calculator service implementation. And what we have done here is we said, okay, when someone calls this method and they pass in a user type, we are going to look to this map to get the appropriate class that we need to actually run and create a new instance of that class. Pretty straightforward, right? And because we know that this class implements the op calculator interface, we don't have to make any, every single one of these are of type op calculator interface. We don't have to initialize them as op calculator service CTO every time. No, that's not necessary. And that would be a pain. Then we'd have an if statement in here and we'd have yet another problem. But they all implement op calculator interface. And op calculator interface requires these classes to implement the calculate ops method. So we know we can call it because the interface denotes that they must have it in their class, which is unbelievably cool, in my opinion. So now we have this super abstract op calculator service that our controller can call, and it never, ever, 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 ever has to know anything about these, actor-specific class implementations, right? We've got these broken out by actor-specific class implementations. Now all of these classes abide by the single responsibility principle, and we are going to now be able to not have if statements anywhere. You don't have them in the controller. You don't have them in this service class here. You don't have them in your individual implementations of op calculator service for each actor type. Nowhere, right? You have these just beautiful, simple, easy to understand classes that you can now, if I wanted to, in this calculator service class, I could just say, I don't want the manager to use this class anymore. I've decided that the manager will just use the same one as the sales associate because their logic is always the same. I don't know. That's maybe a bad example. But my point is, you had to do almost nothing here, right? Almost nothing at all to change that implementation if you wanted to, which is, in my opinion, a beautiful thing. So, long story short, pretty cool stuff. Now let's see this in action, right? I'm telling you it works, but that doesn't mean much unless you see it run. At least in my mind. I trust nothing until I see it happen. So he saved it, and thankfully for once in my life, I got everything right and it actually saved. I feel like I always miss something. And we're just going to open anonymous Apex. Wow, this still has clone interface logic in here. And for some reason, wants to connect to something that doesn't matter, I guess. Oh, it's stuck on a different implementation here. We need to go to coding with the force. There we go. And let's just run this code. So we'll say op calculator controller dot calculate ops, and we'll pass in CTO and see what happens. And hopefully, if everything went right, we get the debug, which we did get, called CTO ops down here. Awesome. So let's just make sure that it actually calls the other things. So we'll put in sales associate, Shazam. We get the debug, which you may or may not be able to see down here. Well, let me just zoom in. Get the debug sales associate ops for sales associate, and let's just give it one more shot for manager and see the magic of the movies or something. And we got manager ops for that one. So as you can see, if you really truly do break your code down into this kind of architecture, you have ridiculously simplified code, and you have an unbelievable amount of flexibility with what we've just produced here. I could add a whole new class implementation. I'd never have to update my controller, and that class implementation would be small. You'd have to do virtually nothing to implement it. This also technically abides by several other principles, and we'll go over that soon too, because this abides by the dependency inversion principle, the open close principle. So, technically the Liskov substitution principle, actually, I think it actually abides by all of them, but that's irrelevant. What we've just displayed here is how powerful and how much, more simplified things can get if you implement just a single one of these principles, which my focus here was on the single responsibility principle, but we did a lot more than that. I got a little carried away maybe. So, cool. Now, let's figure out if you wanted to do something similar in a Lightning Web Component with JavaScript, how you could actually get this to work. Okay, let's figure out how to do this in JavaScript. If you didn't know, JavaScript is not a typed language. Pretty sure if you've worked in it, you've probably figured that out. But what that means is unless you use TypeScript, which is very challenging to use in Salesforce and not quite as useful as it is other places, unless you use TypeScript, which I'm not going to go over, there's no concept of interfaces. There's not really a great idea of, object types in general, right? So the way that this looks in JavaScript is going to be quite a bit different, but it's going to be the same thing, same general concept of abiding by the single responsibility principle and giving your JavaScript a lot of flexibility in the future as well, right? So first things first, let's just create a Lightning Web Component so we can actually do something. I'm going to call this SRP example, maybe. Single responsibility principle example. And I'm going to check this exposed box right here. If you're using Visual Studio Code, don't freak out. I will go over how to do this in the metadata in a minute. The other thing I guess I haven't gone over, of course, if you're this deep into the video, you probably don't care. I'm using Illuminated Cloud 2, which is a plugin for IntelliJ. If you don't know what this IDE is that I'm using to write all this code, I do have a tutorial going over it. I'll put it in the description or maybe link it up above here, and you can check it out. Okay, so say for instance we have a Lightning Web Component, and that Lightning Web Component we kind of want to be reused a bunch of places, but it has logic for different actors and different things, and we want our logic in our JavaScript controllers to still abide by the single responsibility principle, ideally, because its magic works wonders everywhere, not just in Apex. So let's figure out how we would do that, because it is quite a bit different, although it's very similar. All right, so the first thing that we would need to do just to get things kind of rolling here is we'll create a calculate ops method. And right now it's not going to do anything. We'll get back to it. And just real quick in the template, we're going to make a button that we can click here in a second to see it in action. We'll say calculate ops and calculate ops. All right, so back over here. Now, all too often what you end up seeing is just something that goes like in these JavaScript controllers, whether it's Aura or it's Lightning Web Components, is somebody eventually says, something like if, well, we'd have like user type up here. Obviously you'd probably kind of want to dynamically set that, but you'd see something similar to what we looked at in Apex, where it'd be like if this user type equals this time instead of just equals, then call the then we'd call the calculate ops CTL method. And just like in Apex, this can make your controller huge, it can make it ugly, it can make it really hard to maintain. So what do you do about it, right? How do you actually make this abide by the single responsibility principle, work for only one actor, everything, our classes only have one purpose? How do you deal with that, right? It's kind of a whole different ball game, even though you're doing the same kind of thing in JavaScript. So what we're actually going to do is create what are called modules in JavaScript. So we are going to right click on our SRP example Lightning Web Component here and create a new JavaScript file. And we will call this JavaScript file, we'll call it op service. So just like the last one, we need a kind of generic opportunity service class to work with. And then we'll create yet another one called op service CTL. And we'll create yet another one, and we'll just do 2 this time to keep this a little shorter. We don't need to redo the whole thing. And we'll say Ops Service Manager. Cool. And in all of these classes, there is no implementation. I can't do an interface and implement things. You can technically do some weird things to make that work, but I wouldn't personally suggest them. So what you have to do is just choose to put a calculate ops method in here, and we'll just have this log ops for manager, and then you do the same thing in ops service CTO, and you'd say ops for CTO. And unfortunately, there's no interface, so nobody can hold you to this like they can in Apex, right? You can do some things with inheritance, but I kind of would typically recommend against those methods. If you look out there, there's some things with it, but I wouldn't personally suggest it. So I'm not going to go into it. But you just have to basically structure your classes with the methods that you want them to have in common, right? Make sure you name them the same, structure them the same, because nothing in JavaScript is going to hold you to anything really ever. And then in the ops service class, you kind of have to figure out, how do I dynamically call this, right? Without having to rewrite a bunch of code, how can I just have my SRP example controller call to this ops service here and never need to know about ops service CTO or ops service manager or anything like that, right? How can we provide that separation in the same way? And the answer is, yet again, the factory pattern, although the factory pattern looks a little different this time. So we're going to create a third file here, and we will just call this op service factory. And what Ops Service Factory is going to do is basically kind of be our middleman to call the right classes, more or less. So we'll call this, we're going to give it a class property of class type, and we will have a method in here again called calculate ops. And we will also give this class a constructor, just like in Apex, how you would normally in Apex, right, or typical object-oriented languages, your constructor would be the name of the class itself. But in JavaScript, you just call the constructor constructor, right? So we'll say this dot class type equals the class type that we actually need to pass into this constructor here, and set it equal to class type. And then down here we will say this dot class dot type dot calculate ops. So again, we kind of got this really abstract implementation. What we're going to end up doing is passing in one of these class types, the ops CTO, service CTO, or ops service manager, and our factory is going to figure out, going to know what class type that is and call the calculate ops method that we've made sure that we've implemented in both of these classes here. All right, now what do we actually do in the op service here? That is the next question, right? Well, yet again, we're going to say calculate ops. And this time, however, we're going to pass in a user type. And basically what we're going to do at this point is say one more thing. We will create a variable class type up here. We actually technically don't need to put this here. We can just make it here. And why is it complaining? Right. I need to not make that a const. Okay, so the we're going to figure out based on the user type which class type we should actually initialize, basically. So here we're going to say if user type equals CTO, then class type equals new op service CTO. Else if user type equals manager, then class type equals new op service manager. There it is. And then down here at the bottom, once we get through however many if-else statements we actually need, then we're going to say const op service factory equals new op service factory, and we are going to pass it this dot class type, or we're just going to pass it class type rather. And from here, we've got one last line to write, which is calculate ops. Now, let me just explain a couple of things that were just kind of happening on the fly in the background here that I don't want to overlook. Number one, when I started initializing these class types here, Illuminated Cloud is nice enough to import things for me instantly. But you might not have that happening for you instantly. And basically what this is doing is it's saying import the ops service CTO class here, and so that I can use it. And the reason that this is a dot here is because this is local to my actual Lightning Web component that I've built. So the SRP example component over here, you can see within its folder, I have all of those files. So as long as it's within the folder and those files are in there, you put a dot here. If you created these separately outside of the Lightning Web component, so you made like a brand new Lightning Web component that was just a module like this, then you'd put a C here instead. I do have a video that goes over all that, so definitely check that out. I'll put it in the description too. I'm going over way too many things, I feel like. And okay, so those things were imported, and the other thing that I'm basically doing here is assigning this class type variable a op service implementation effectively. So based on the user type that's coming in, I'm assigning it an implementation of our op service, and then I am passing that implementation of our op service into our op service factory, which in the constructor takes a class type and assigns it to that class variable called class type. And then it calls the calculate ops method in here. So last thing that we've got to do is actually call it, right? So we need to say op service, and again you can see it imported that for me up here, so don't overlook that. You have to import this too. Say op service, it is this, right? Yep. Calculate ops. Oh, the reason that it's not liking that makes sense. I'm kind of jumping the gun here. We need to say const op service equals new op service. And then we'll say op service dot calculate ops, and we will pass it the user type, right? Obviously, in a perfect world, you'd have like a way to dynamically push in this user type, but I'm not going to go too deep into that. We don't need to get into that. You can figure that out if you need to do that. All right, so we're calling the op service class, this guy, and this op service class, based on the user type we're passing in, is determining which, op service implementation we need to actually run. And then from there, we pass it to the op service factory, which just generically calls whichever, op service we've decided we need to run, right? Which is pretty cool. So let's see if this actually works. The first thing we'll have to do to actually put this somewhere is, number one, go to the metadata. And if you don't have this isExposed tag and it's not set to true, make sure to do that, especially if you're in Visual Studio Code. And then we'll create targets, and we'll create a target, and we'll make this available for Lightning record page, I think. Or is this lowercase? I'm gonna forget. No. Okay, cool. And everything's saved, so that's great. Real quick though, let's go back and fix a couple of things that I made mistakes on before we waste any time. If we go back to the op service class, I was clearly not paying attention, and I named my variables the same name, which causes variable collision, and that's not great. So before I had this named op service factory, I just stuck a 1 on it. That's a horrible thing to do. Please don't do that. But now my variable names are different. And that way, this variable up here and this variable down here don't collide. Second thing is I did literally the exact same thing over here, which was fantastic. So make sure that, again, you don't name your variables the exact same thing, or you are going to experience problems that you won't love. And the last thing is I foolishly forgot to add an on-click to my Lightning button. So make sure to come back here to the actual Lightning component template and add an on-click that calls your calculate ops method in the JavaScript controller here. Cool. And then we are good to go. I hope. So, all right, let's open up Salesforce and actually try this out. See what happens. Hopefully it works. No promises. And we'll go to setup, go to Lightning App Builder. If you don't know how to get to setup, well, you probably weren't watching this long anyway, but you go to the gear and then you go to setup and then you go to Lightning App Builder. And if I already have a bunch of Lightning pages, I'm just going to go to the Lightning page for opportunity that I've created and hit edit on it. And I have an old version of this button in here that I need to remove, and we'll grab the SRP example button that we just built together and hit save and go back, and we'll go to an actual opportunity and actually click the button and hope that we see, what should we see? We have a user type of CTO. So hopefully in our console we get ops for CTO popping up. So let's inspect this and click the button. And thankfully we got ops for CTO to pop up, which is awesome. So let's just real quick change this to manager and make sure that it runs as expected for manager, which it should give us ops for manager, just to see that this all works out. So we'll change this to manager, save it. We'll come back over here. I'm going to do Control-Shift-R to hard refresh the page so nothing gets cached. And we are going to click the, let me clear this debug log or this console over here and hit the calculate ops button, and you can see we get ops for manager this time. So pretty cool. We've been able to separate everything out into its own kind of JavaScript classes, or what are more frequently referred to as modules. These are modules that have a class in them. And so we've been able to have our Lightning Web Components abide by the single responsibility principle as well. It looks a little different. It feels a little different in JavaScript, but the same outcome was achieved, and that's great. And you know, just in case if you weren't aware, you know, you could import Apex classes here and have your ops service for CTO call your Apex class from here, or whatever else. There's a lot more to talk about with that, but generally speaking, I think we have the idea now. Single responsibility principle, we've implemented an example in both JavaScript and Apex, and I hope you have been able to see how powerful it can be in simplifying your code if used properly and in the right places and all that kind of stuff. So, yeah, hopefully this was helpful. And next week we will go over the open-close principle, which is definitely a good time. So, yeah, if you like this video, make sure to like it, subscribe, consider becoming a member because it helps grow this channel considerably, and share it if you really think it's that cool. But anyway, guys, I will see you next week. Thanks for watching.